11.3, game theory and linear programming. If you think about what we've already done, in 11.1, we talked about strictly determined games. And that meant that everybody did the same thing over and over again. The role player, the column player, they're going to do the same thing every single time. And there was a saddle point, and the saddle point told you the value of the game. But that's not going to happen every single time. Sometimes there's not a saddle point. And if there's not a saddle point, then the game's not strictly determined, and the players are going to have to mix it up. Do this sometimes, do this sometimes. Okay? So in 11.2, we had a payoff matrix that was a 2x2. And how we found those strategies was we did some matrix multiplication. 11.3 is going to be even harder. It's not a 2x2 payoff matrix, and we're going to have to use something called Simplex Method. And so this will be good review of Simplex Method, since we haven't done that for a couple of months now. So here we go, how to find optimum mixed strategies if it's not a 2x2 matrix. First thing we're going to do is check for dominated strategies. So you look for a row that maybe dominates. I don't see any rows. You look for a column, and you can see -6 is better than -2, 0 is better than 1, -4 is better than 2. And so the column player is never going to pick column 1. They're only ever going to pick column 2 over column 1. They'd pick column 2 or column 3, but never column 1. So we can reduce that matrix down to a 3x2 like this. After we do that, we're going to have to add a number n so that no entries are negative. So when we look at this, I don't want any negative numbers. It looks like if I add 9, that will make all of the entries non-negative. Okay? So I basically look for the smallest number and add that opposite, I guess. So if I add 9 to each of the entries, I would get 3, 19, 9, 0, 5, and 1. So I've got a new matrix there, okay? I've got a new matrix, a 3x2, no negatives. But keep in mind, always keep in mind throughout this problem that we have these variables here, x2 and x3. So there's an x2 and there's an x3 right here. I didn't quite give myself enough room, but you've got the second column and the third column showing up, but not the first, okay? So problem 2, or step 2 says form a maximization problem with slack variables. Now I'm going to skip a step here, but basically what we want is, since there are 3 rows, there are going to be 3 slack variables, okay? Each of the rows is going to represent an inequality and is going to need a slack variable. If you recall, a slack variable turns an inequality into an equation, and that's necessary for doing what we're going to do here with the simplex method. We want to form an initial simplex tableau and then perform the simplex method, okay? So what we have then, if you look at your variables, we have x2 and x3. And then we're going to have S1, S2, S3. And then we're also going to have a Z variable. I know we don't see a Z variable, but that's from the maximize. And that's the problem, or the part that I skipped. If we were actually writing down this step, we'd say maximize Z equal x2 plus x3. Okay, that's actually kind of in the way, so I'm going to get rid of that. But let's go back to here. Maximize Z equals x2 plus x3. That would be at the top, and then we'd have some inequalities and stuff, and that would be the maximization problem. But we want to set up that simplex tableau. And so look at the first row. We've got 3x2, 19 x3, and then we had to insert a slack variable for S1. We don't have an S2, an S3, or a Z, and then there's a vertical bar, which represents our equal sign, and it's going to equal 1. Okay, it's going to equal 1. I know we're missing that step, but that's what you're going to have to add in there. So then we look at the second row, and we have 9 I don't know why I can't make a 9. 9x2, 0x3, 0s1, there's 1s2, 0s3, and 0z, and it equals 1. And then we look at our third row, we've got 5x2, 1x3, no s1, no s2, but there's 1s3, there's no z's, and it equals 1. And then we put an underline here, and that's where we put our maximum function, okay? Remember, that vertical line represents the equal sign. So there's your vertical line right there, and these variables are on the wrong side. So remember, we have to subtract those over. You have to subtract those variables over to the left, and so that makes a negative 1 for the x2 and a negative 1 for the x3. I didn't need any slack variables because this one was already an equation. I had a z, and then I cleared everything out from the right, so that's going to equal 0. There's my initial simplex tableau. I know that's kind of weird. That's kind of confusing. We haven't seen that in a while. I skipped a step, but there it is. Bless you. And then I do the simplex method. Now I'm gonna just kind of wave my hands over that for now. We'll do one with the simplex method later, but for now, just understand that we've done the simplex method to get to here. Okay, so that's the final tableau after the simplex method, and we need to be able to read the strategies from that table. And it's not quite the same thing as when we read the solutions from that table. Okay, there's a little bit more to it. So think about what we've done in the past, okay? There's no x1, so let's just say x1 equals 0. x2, if you can remember way back, what we did was we said, well, all these zeros means I have to look at this 9. And if I look at this 9, then that's going to force me to look at this 1. x2 is going to equal 1 over 9. And x3, if you look at x3, this column, you're going to look at this 57, and this 57 makes you look over at this 2. x3 is going to equal 2 over 57. Okay? Now, that is not the strategies. That's just your x values. Now we look at S. Look at the slack values. And this is a little bit different because if you recall, when we had a bunch of numbers here, we just said S1 was 0. Okay? S1 was 0. We're not technically finding the slack variables. We're doing something a little bit different. So I'm going to do something a little bit different here. I'm going to look at this bottom number 9, which makes me look at the 25. Okay? So S1, I'm going to say is 25 over 9 here. I can't draw 9. There's something about a 9. I just can't do it. There we go. S2 then. You know, normally we'd say that's 0, but here we're going to look at this 16. It's going to be 25 over 16. And then S3, kind of weird to look at this 0. and say 25 over 0. Obviously, that's undefined. But I don't really care about the slack values anyway. Doesn't really matter there. Okay. So just go with me for a second. And then let's talk about Z. The Z value, you're going to do 25 over 171. Okay, so that's pretty similar to what we did in the past. And now in this box, this is what we need to do to find those strategies. Okay, the role player strategies are the slack values, sort of. Okay, sort of. We're going to put an asterisk by that and write the word flip. Okay, it's not the slack variables. It's the slack variables if you flip them. Okay, so if you look at the role player strategy, his row 1 strategy is 9 over 25. Just take the reciprocal. And row 2 is going to be the reciprocal, so give me 16 over 25. And then row 3, if you take the reciprocal, you're going to get 0. Okay? So what that means is the role player is going to play row 1 9 25ths of the time, and row 2 16 25ths of the time, and then row 3 never. Okay, that's what that means. One way to check your work here is to notice that these numbers add up to 1. That should make sense because all of our vector numbers like this are probabilities and they should always add up to 1. Okay, that's the row player. The column player, you have to do something extra. You have to take those x values that we just found times the reciprocal of z. Okay, so if this is z, then I want to multiply times that reciprocal. So what? That means times 171 over 25. Okay. I'm going to take each of those x values times 171 over 25. And obviously this one's 0. 9 goes into 171. $19 times. So that's going to be 19 over 25. And 57 goes into 171 3 times. So that's going to be 2 times 3 is 6 over 25. That's my column strategy here. Okay. So we've got 0 and 19 25ths and 6 25ths. So again, you can check your answer because you can see that those numbers add up to 1. That's a good thing. All right. This says column player plays column 1 0 and column 2 19 25ths of the time and column 3 6 25ths of the time. Now to find the value, what we do is we take the reciprocal of z, that's what that says, the reciprocal of this, minus n. Now remember, n in this problem was 9. Okay. Back up here when we added that number to get the non-negatives, we added 9. So maybe I should have written that n equaled 9 there. Okay. So we're going to subtract that 9 back just to kind of zero us back out. So let's take reciprocal. 171 over 25 and subtract off that 9. Negative 2.16. That's the value. Negative 2.16. So in this example, it looks like the column player would win 216 every play.